Today we're going to talk about factoring trinomials. Okay? So opposite of FOIL. So what I'm talking about when I say opposite of FOIL, it's been a few days since we've been learning about polynomials. I understand that. If I had x plus 2 times x minus 3, can you please FOIL that out? Expand that. Good question. First, outside, inside, last, right? That's where we use our arrows. So please expand or multiply this. And no, you can use other methods. Distributive property works great. Okay? X times x. X squared. So then we take the x and we multiply it by negative 3. Negative 3x. Then what do we do? 2x. 2 times the x is 2x. And then 2 times negative 3 is minus 6. Then what do we do? Okay, let's not argue. Like terms? Good. Yeah, you guys are rusty. Rusty. Shine you up a bit. Okay? Well, we collect like, oh, it's not. Yeah, it's definitely not. You are paying attention. That's good. What did it actually equal to? Negative 1x. Thank you. So, that's distributive law. Okay? Our mission, you have no choice. You must accept. Okay? Is to take a trinomial. We're going to do type 1 trinomials today, and I'll explain what a type 1 is in a second. Is to change it from an expanded polynomial, trinomial, into the factored form. Okay? We are going to factor. So that's our goal today. So when we factor, it's multiplication, right? We can think of the expanded form as, that's like our area. And we can call each one of these dimensions, one of them's like your length and the other one's like your width. Would you agree that area, like this area, is equivalent to the length times the width? Okay, so if you wanted to use algebra tiles, and you're given your expression for your area, so what's the expression here? We have an x squared plus how many x's? 6 x's and how many ones? 8. We want to take this and form a rectangle with these shapes. Okay? X squared always goes in the corner, and then you'd have to arrange your x tiles so that we can make a square of 8 ones. So the 6 x's would have to go by 4 by 2 in order to fit the 8 ones into a nice rectangle. So then you could see now, what's the dimension of the length or the width? The top. I'll say the top. X plus 2. Just 2. Because we just want the dimension. Well, we're talking about the dimension. So we know that this dimension is an x and that dimension's an x. And together, when you multiply, it gives you that x squared. So this is 1, right? This is a dimension of a 1. And this is 1 wide. Okay, we're talking about the dimensions. We're not talking about the area, the actual tile. I'm saying what's this measurement across? So this measurement across, we have this here is an x dimension. This is a 1 and a 1 dimension, like measurement. Just across. We're just doing the length or the width. Okay? So what would be the dimension of the other side? It'd be x plus what? What's that length here? How many units? 4 units. Yeah, that'd be 4 units. So x plus 4. So one of the sides is x plus 4, and the other one is x plus 2. And together, if you multiply that, that will give you your area of x squared plus 6x plus 8. Okay? So as a product, x plus 4 times x plus 2. Is there another way you could write that? Could you write it as x plus 2 times x plus 4? Yeah, same thing, right? When you multiply 3 times 2, 2 times 3, it's the same thing. And the area would be the expanded form, the x squared plus 6x plus 8. That's the area in expanded form. The area as a product is the length times width. Okay, so that's with algebra tiles. Let's try one together, and then we'll go into algebraic. Okay, so here, what are we given? X squared plus 5x's plus 4. Okay, we need to form a rectangle. The x squared always goes in the corner. I don't know if you want to shade that. It's up to you. Just use it. Okay. I mean, they're all positive, so. Okay, now what? Now we need to figure out how to place the 5x's because we need to have 4 1s. Right? And the 4 1s are going to go in the corner of the x squared, across from it. Something like that. So how would we arrange them? Would we put 2 x's and 2 x's like this? Would that work? Wait, that's not enough. I need 5. So would that work? No, because how many 1s would that be? That would be 6. So that's not going to be it. Undo, erase. Put 4 on one side and then 1 on the other. Does that equal 4 1s? Yeah, that does. Okay, that'll work. That gives me the 5 1s. I should crayon it in. Okay, good enough. Okay, so what are the dimensions here then? What's the length? X plus what? 4. What's the width? X plus 1. And so factored form, x plus 4 times x plus 1. So that's the factored form of x squared plus 5x plus 4. Okay, that's algebra tiles. I'm going to show you another method. So why don't we turn the page? We're not going to do that one. Okay, keep going. Okay, so there's a few different methods we can use to factor. I'm going to show you 2 methods, okay? And so we're going to kind of skip a lot of this. I do want to talk about the bottom of this page here. Let's actually go through this, okay? Because it's a good practice. If I want my sum to be 12 and my product to be 20, and I need 2 numbers to do that, would you agree that 2 and 10 would work? 2 and 10, if you add them together, does that give you a sum of 12? Yeah. Product of 20? Yeah. You can find 2 numbers that sum to 9 and add to 20. Sorry, multiply to 20. 4 and 5. Good. It's like a puzzle. Okay, I want you to find 2 numbers that sum to 4 and product to 4. 2 and 2. Okay. Sum of -9, product of 18. Okay, 3 and 6, as long as the numbers are what? Both negative. Would you agree? Yeah? -3 times -6 give you positive 18, and then adding those together is -9. Okay, sum of -15, product of 14. Now, one way you can do these is take your product, make a product tree. What are all the ways to multiply to 14? 1 times 14, 2 times 7. So which one can we actually make a sum of -15? 1 and 14, as long as what happens? Are they both negative or just one of them? They both have to be negative. Now notice, if we want a positive product, all the positive products, the signs of the 2 numbers are the same. They're either both positive or both negatives. Okay, let's try this one. Sum of negative 1 and a product of negative 6. So how can you multiply to 6? 1 and 6 and 2 and 3. So what would be my two numbers? We want to sum to negative 1. We want the bigger one to be negative, so that our sum, would you agree that negative 3 plus 2 is negative 1? Okay, guys? So always GCF first if we can. In the previous examples, the first coefficient was a 1, and so there was no GCF. But if there is one, we have to. And I know this is a lot on your brains because you've been like mush for 2 weeks. But stay with me, okay? It's a very important lesson that you're going to use all the time. Okay, so is there something we can factor out of those first 3? We divide all of those by. Conveniently 4. What is 32 divided by 4? Good. What's 48 divided by 4? How about 12? Okay, so now I'm going to use, now we have a simple trinomial inside, so let's factor that. Only way to multiply to 1x squared, 1 and 1. Right, because the coefficient of the x squared is a 1. Okay, 12. We want to multiply to 12. Add to negative 8. 6 and 2. Now, what do we note about the signs? For product of positive, but a sum is a negative, they both have to be negative. Okay, so checking my diagonals, does the product of the diagonals, do they add to negative 8? Yes, so we have our factored trinomial. The 4 still goes in front, the GCF. What's going to go in the brackets? Good, right? This has the x and an x. So x minus 6 and x minus 2. It's going to be a lot less writing than the other method. We're done. There's our answer. Okay, how could you check your work? There's actually a couple ways. One is you can expand it and make sure that after you FOIL everything out and expand it, you have the same thing that you started with. The other way is with your calculator, and I'm going to show you how. Okay, grab your calculators. Okay? Okay, so what I'd like you to do is you need to choose a number for x. Okay?
3.
Sure, 3. So type in 3, and I want you to push store. So STO, which is right above the on button. Okay? Push X, which is right below mode. And push enter. Okay? We're good there? What we just did is we said, if you push X and enter again, you stored your X as 3. Your calculator is registering X as 3. Even if you push clear. You have to reset, yeah. Okay? So again, one more time, you pick a number. You could use 4, you could use whatever. I'm going to use 3 just because that was the first number yelled out. Okay? Store, STO, which is right, my cursor's right there on STO. STO for store. Okay? X, which my cursor's on X right now, blinking really fast. And enter. I'm just somebody wanted to see it again. Okay? Okay, so you did it again, yeah. Okay, so what you do is I'd like you to type in, we're going to type in the original question. 4x squared minus 32x plus 48. There's 2 ways we can do this. I'll show you. Okay? I got negative 12. Depending on your number, okay? Did you use a minus sign instead of a negative? Okay, then, guys, shh. Then we type in our answer. 4 times x minus 6, x minus 2. Okay, we should expect to see the same answer, negative 12. Okay? Okay? So as long as these are the same, then your work is correct. There is actually another way to check it without storing. See if I can remember. Oh, test. Okay. There's one more way, and you don't have to store a number to do this one. Just want to make sure. So, in a text, you can also do a text. 1 is true, 0 is false. Okay? So, a test, another thing you could do is you type in your original, 4x squared minus 32x plus 48. The test feature is second math. You see test on your calculator there? I have no idea what to do with it. It's better. Okay, so second math, we want to use the equal sign. So we're saying, does 4x squared minus 32x plus 48 equal, now let's type in 4 times x minus 6 times x minus 2. Okay, if it gives you a 1, that's a yes, that's true. Those are equal to each other. If it gives you a 0, it's a false. So say I factored and I actually put in, okay, multiplies to negative 12. I put negative 4 and x minus 4, x minus 3. It gives me a 0 because that's false. I factored. That's another way to check without having to store a number as x. So either way works. Okay? I would like you to try B. Okay, start with GCF. Start 3x. GCF, not KF. GCF. What's on the brain, hey? It's same stuff, don't worry. Just yeah, just a little interesting. Okay, so if we can GCF, we must always, that's a first step, check for GCF. I can't tell you how many students on their exam all of a sudden forget about GCFs. Because you see a trinomial and you're just so like gung-ho to get factoring it that you forget to check for the greatest common factor. So we can divide everything by 3x. We need to pull that 3x out. Now we want a product of 10, sum of 7. And so you should get 3x times x plus 5 and x plus 2. Was that okay? You can check your answer. So if you checked your answer in your calculator at this step here, it would give you true. Yes, this is equivalent to the original thing, but you're not done because you can factor that trinomial further. Okay? All right, turn over to lesson 4. Okay, so what page is this? What page are we on, guys? 343. Okay, so all of this is all the same thing. Okay, the variables are different. What's different is I'd like you to look at page 3A, number 3A. Okay, that's all we're going to do. On page 344, turn to 344. Okay, so where do I start with this? Okay, is this a simple trinomial? Yeah, it is a simple trinomial, and it's a little different in that the middle term is an xy as opposed to just an x, and the last term is a y squared. Okay? So, but that's okay. Don't be afraid. It's all good. Okay? So again, sum product. Now, we're multiplying to a positive, and our sum is a positive, meaning both numbers will be positive. Okay, so would 15 and 2 work if they're both positive? No. What would the numbers be? 10 and 3. Okay, 10 and 3. 10 times 3, would that give me the 30? Yeah? And the diagonals, do they add to 13? Yes. Okay, and the signs were both positive. Now, what's different about this is just the variables, right? We want this column to multiply to x squared. So that's where we always put our x and x. We want this column to multiply to 30y squared, not just 30. So what would we do? Y and y. And so the factored form becomes x plus 10y, right? Here's the first, and here's the second. X plus 3y. And if you look at actually your diagonals, if I put the variables in there, we get a 1x times a 3y, which is a 3xy. A 1x times a 10y is going to give you 10xy. This is how we get 13xy. Okay? So it's the same thing. We just have an extra variable in there.
Wouldn't 30 be xy squared again?
No.
Oh, wait.
Okay. Well, and you're doing like, think of it, a FOIL, x times x, right? That's this part here, x squared. Here's x times 3y, that's this diagonal here. 10y times x, that's this diagonal. And then 10y times 3y, that's this box here. So those 4 parts are that FOIL. You can check your answer. Okay. It's a lot of writing in there. Okay, let's do the next one. Oh, let's do C and then call it a day. Okay, you try it yourself. You try. Okay. Don't forget what? Greatest common, good. Make a factor tree for the product. 1 times 84, 2 times 42, 3 times 28. Thank you. That's helpful. 4 times 21. 5 won't go in. 6 will, because 3 and 2 both go in. So 6 times what? 6 times 14? 7? 7 and 12? How about 8? There is no 8 does not. You're right, because 84. So we're done, because 9 won't, 10 won't, 11 won't, and we go back to 12. So any of those, can we make negative 5? 12. Yay. Oh yeah, so because our product is negative, you know one number is positive, one number is negative. Okay, whenever your product is negative, you're going to have 2 different signs. And you want to add to a negative 5, so which one's negative? The 12 would be negative, because you want the larger one to be negative. So this is 1 and 1, and this becomes 7 and negative 12. Okay, you can put your variables in now if you want. Just check your diagonals. Negative 12 plus 7, yes, that equals negative 5. So factored form, don't forget to put what? Where? 3 has to go outside the brackets. Good. And then we have 2 sets of brackets. What are they? A plus 7b and a minus 12b. You could put the a minus 12b first and then the a plus 7. It doesn't matter. 7b. Okay? There's your answer. Now, again, you could use your calculator to check this. I like using the test. You can also store a and b as different numbers. If you use the test, you can use a and b. 3a alpha math is a squared minus 15a alpha apps is b minus 252 b squared. Okay, and then I want to test. So second math, is that equal to my answer 3 times a plus 7b times a minus 12b? If it's true, it'll give me what number? 1. Cool. Okay, that's That's today's lesson. Super, incredibly important. In Math 20-1, I would say 50% of the lessons we've used factoring. Almost that high, maybe a little less, but pretty close to that. You have to be able to do this. And it's just like prerequisite knowledge. It's not something that's going to be walked through again. You need to understand this and be able to factor. Okay? It is foundational. It's like knowing your times tables. Okay? It is. We're 11. Okay.